Welcome to Tripoli/ECE 301 Digital Electronics, Lecture 11, Part 1. In this lecture, we will discuss about VHDL module, how to write the VHDL code for combinational, sequential, and arithmetic logic circuits. So now come to lecture outcome. So in this lecture, we will discuss about VHDL basics, VHDL anatomy, VHDL modeling approaches, and examples of VHDL using IC design suite. So now comes to VHDL. So VHDL is a nested acronym. So here HDL stands for hardware description language, and V is for VHSIC, which is very high scale integrated circuit. So VHDL used at different levels. So it could be behavioral, it could be data flow, or it could be structural. So behavioral is like more abstract, describe what we want, not details of how, a bit subjective. And data flow described at the level of movement and manipulation of data, which is known as R register transfer level, RTL. And structural is low level, basically connecting together blocks and gears. So whenever we're writing the VHDL code, we'll focus on these three kinds of leveling. We can call it as behavioral VHDL or data flow VHDL or structural VHDL. So this is the anatomy of VHDL, like how a code looks like. So initially we will call the library functions. So the IEEE standard package is used here, and the second part is the entity function. So description of input and output of the system is given there, and the third part is the architecture part. Description of behavior of the system is given there. Altogether it is called VHDL module. So you can see a skeleton, basic skeleton of VHDL module. So as we already discussed, we have the library version, just library IEEE and IEEE.std logic 1164. We usually use that convention for usual VHDL coding, and our second part is the red colored entity part. So within this entity we include the port. Port means what is our input and what is our output, and this is kind of the basic structure or skeleton. And our last part is the architecture. So within the architecture we have the begin and end. So within that we put our algorithm, so what we want to implement. So this is a very basic or simple circuit, as we already have seen it before. So we'll learn how to write the code using that skeleton for the simple circuit in the next slide. Okay, so as you have seen this circuit before, so we'll learn how to write the VHDL code for this circuit. So as you can see the rectangle box, just consider it as a black box. What I mean by that is, like, you have the port, like this is your input and that is your output, which is uh, seen from the outside world, but whatever you have within that black box we cannot see from the outside world. So that's why we're calling or considering it as a black box. And now think, whatever you have outside the box, so we call it port. It could be either input or it could be either output. So here, if you look at the skeleton, like we start with entity, then we give the name of that file. Here I have given lecture 1 example 1, then is the convention, then port. Within port we declare the input and output. So here we have ABC, these three port. ABC is our input, we write it ABC in, then standard underscore logic, that represents our A is single bit. If we have multiple bit or more than 2 bit, we usually call it vector. So the convention is bit different, and we'll discuss it in the next slide hopefully. So X and Y is our output, so we call it X and Y out, and we call it standard logic. So we started the entity and we end the entity, and you need to write the name as well. Just one thing you need to be careful, like here after every port there is a semicolon, but for the last one there is first bracket. You need to close the first bracket for port and then semicolon, so there is nothing. So most of the students, they forget, they give the semicolon here, and they find the error whenever they do the simulation in the software. Okay, so this part is done, the entity part. The second part is the architecture. So we give the architecture there, then we discussed about three types of labels. One is behavioral, structural, if you remember. So here we call it behavioral because we are just describing the behavior of the circuit. Or you can put some other name if it is related to your circuit. It's not fixed really. And then you give the name and the other convention. Then you start begin. So after begin you give the architecture, write the equations. Like here we want to learn or get what is x. So x will get x equals a and not b, and for y equals not b and c, and end behavior. So you started the architecture, you end the architecture. And this is called actually assignment. So x equal a and b, actually a and not b. That means we are assigning x from a and not b, and y from not b and c. So this is a typical software simulation. So we will use IC Project Navigator. You will be provided the link of the software. You can test it. So this is the code what you already have seen, and if you simulate, it will look like this. So you can see the RTL, like from here, implementation design. After that, view RTL schematic. If you, after running, if you click this tab, so it will pop up this kind of things, which is similar to what we are trying to implement. So it will look like this. So in the first part, we already discussed about how to write a VHDL code for a simple circuit. So now this is your first assignment. So you have given a simple simple circuit again, similar to what we have seen before. So this is the AND gate. It has two input here. This is inverter, and this another AND gate, and this is your OR gate. So two AND gate is connected to OR gate, and this is your output. So here you have three input and you have one output. So you need to write the VHDL code. So to write the VHDL code, you need to write the library, call the library function first. Later on in the port, you need to include whatever input and output is, and also this is your output, and also maybe you need to think about the signal as well. You can avoid it as well, maybe, so it's up to you. So I suggest you pause the video here and try to write the code for yourself. I'll check it in the lecture session. So in this question you have given another example, but you have given in terms of truth table. So what you need to do, you need to write the VHDL module for that. Okay, so your first task is you need to identify your entity. If you look at here, so you have the input, that means you have two input or entity A and V, and you have the output, so you have two output W and X. So you need to write the entity part and later on your architecture. So for this input you will be expecting this kind of output. So how we can write it? Okay, so before going to the main program, I want to emphasize this part. So this is your skeleton. So what a skeleton means, right? You need to write the entity part here. So entity, the number of your problem, and port, within port you need to declare your input and output, right, and end of entity. So this is the first portion, the entity part, and second one is your architecture. So the structure is architecture, and the behavior of architecture you can write RTL, name of the architecture, vgain, then end architecture. So within vgain and end architecture you will write your main program here. Okay, so let's come here. So this is basically your expected VHDL code. So here you have A and B as the input. You write A in standard logic, B in standard logic, and W and X is your output. So W and X is your output. But if you look at here, your W is not a single bit, it's a vector. So that's why you need to write standard underscore logic underscore vector, and you need to take the dimension. So this is actually 4 bits, so you need to write 3 down to 0. So it's not shown here, but you need to write it 3 down to 0. And for x is single bit, so you can write as it is. Okay, so end of entity. Then within the architecture, so after begin, so you write your main code. So if you look at here, so you're expecting x and w in terms of a and b, right? So you need to make a relationship between x and ab and w and ab, so that you can get the expected output based on your input. So here it's written here x equals a and not b. So why a and not b? So if you look at here, so if you and a with not b, then you will get the x. Okay, so that's how it's written, but you can find any kind of relationship similar to this. So a is your 0 0 1 1 and b is your 0 1 0 1, but if you take b prime, that will be not b, right? Then and together, so you'll get this one. And for w, so for w, so you can see there's a couple of situations. So like here, when ab is 0 0, then you're getting this one, 0 1 getting this one, 1 0 this one, 1 1 this one. So that's why you write w equals 4 0 when a and b equals 0 0. So this and is putting things together. That means a is 1 bit, b is 1 bit. So a 1 bit, b 2 1 bit, altogether 2 bits. So there is a double quotation for vector. But if it is a single bit, then single quotation. And next one is 1010. So w1010 when ab equals 0 1, and 1100 when a and b equals 1 0. And last one, you don't need to write the condition, so you can write else. That will be 1001. End of architecture. This is your final code. So just remember here, so here you have the vector, so you need to declare that in terms of vector. Things you have couple of conditions here, so you can also check this in the software as well, and it will show you the schematic based on this function. So you have given one assignment here. So you have given A, B, C input and F and G as an output. So you need to write the VHDL code for this, right? So what you can do, so you can follow the previous example what we have done. So you need to identify your input and output, then declare it within the port, and within the architecture you need to make a relationship for F with in terms of A, B and C, and G in terms of A, B and C. So then write it within the architecture, then you are done. So if you find any difficulties, you can let me know in the class. Thank you.